This lecture is about associated colloids, otherwise known as micelles. Associated colloids or micelles. These are substances which act as electrolyte at low concentration and behave as colloids at high concentration. For example, if soaps or detergents are put in dirty water, we get micelles. Micelle formation. What are the conditions for micelle formation? Micelle formation occurs only at a particular temperature and concentration. The particular temperature is known as Kraft temperature, and the concentration concerned with it is known as critical micelle concentration. Below this concentration, micelle formation does not occur. On dilution, micelles will revert back to its ionic state. Usually, soaps have a critical micelle concentration between 10 raised to minus 4 to 10 raised to minus 3 moles per liter. Micelles are nothing but cluster of molecules containing more than 100 molecules. Mechanism of micelle formation. Before moving on to the mechanism of micelle formation, first we'll learn what is the structure of soap. Soaps are sodium or potassium salts of fatty acids. They have a hydrophilic head and a hydrophobic tail. The hydrophilic head is water soluble and the hydrophobic tail is oil soluble. Soaps are usually represented by the formula RCOO negative Na positive, where R is the hydrocarbon residue. Represents the structure of soaps and detergents. Both have a hydrophilic head and a hydrophobic tail. We will see the mechanism of micelle formation in detail. Soap or detergent is added in small amounts in water. It ionizes. That is, RCOO negative. When put in water, it forms RCOO negative plus Na plus ions. Here, the soap will align in such a way that the hydrophilic head points towards water and the hydrophobic tail moves away from it. But when appreciable amount of soap is added to water, initial position of the soap molecules get reverted. That is, the hydrophobic tail attacks the dirt particles, whereas the hydrophilic head remains away from it. Basically, dirt consists of dust along with grease or oil, so it is organic in nature. The organic part of the soap molecule, that is the hydrophobic tail, attacks the dirt particles. Many soap molecules attacks the dirt from all sides, forming a cluster of molecules called micelles. Micelles are cluster of molecules consisting of dirt and numerous number of soap molecules. When soap is added in appreciable amounts in a bucket of water, micelle formation occurs. This occurs at the critical micelle concentration. Basically, dirt is consisting of dust along with grease or oil. You know, oil is organic in nature. So, the hydrophobic tail attacks it. Once it attacks that, it becomes soft and gets emulsified. The hydrophilic head remains away from the dirt. It carries a negative charge on it. Many number of soap molecules, when surround the dirt, we get the micelles. That is, the micelles are cluster of molecules with dirt. All over, you find negative charges are distributed. Since these are negatively charged particles, no two micelle molecules come close by because of repulsions. The first figure shows how the molecules of soap get aligned when a little bit of it is added to a bucket of water. You can see that the hydrophilic head is pointing towards water, whereas the hydrophobic tail moves away from it. But at CMC, the position of the hydrophobic tail is reverted. Dirt gets attacked by the hydrophobic tail and the hydrophilic head moves away from it. The structure reveals it is a cluster consisting of dirt and many molecules of soap. The condition for formation of micelles. When soap is added to water, the soap becomes the biosurfactant molecule. It reduces the surface tension, and when it reaches the critical micelle concentration, you find that the surface tension is minimized and cluster of molecules are formed. Finally, the emulsified micelle is washed away with water on scrubbing. This explains the mechanism of cleansing. Both detergents and soaps follow the same mechanism as their structures are one and the same. Hope you have understood this.